Hello there, this is Algebra 1. We're talking about factoring today when you've got a number in front of the x squared. In math speak, we say the leading coefficient, or the a, is not equal to 1. Let me tell you, it's going to be a wild ride. So get your popcorn ready, and let's go. Now, first I recommend that you go ahead and you read the first couple pages up through the examples. And I'll wait a few seconds so you can pause the video and read that and then come back. Remember, you're not required to understand it perfectly the first time you read through it. It's just meant to be an introductory experience, so then later on you can understand what's going on. So I'll wait, pause the video. I promise to be here when you come back. Hey, welcome back. All right, so there were a couple examples there. They're laid out in a way that's kind of best for text purposes. You're going to see these examples do the same things, but they're laid out a little bit differently. So let's see. We got the first one here. We got a 2x squared plus 11x plus 12. So first of all, the leading coefficient, which is the 2, needs to multiply by the constant term. That's the 12. Now that makes 24. It's not that exciting. But now what's interesting is we're after the factor pairs of the 24. Now, I've listed them all out. You may notice later on that you don't need to list them all out, and that's fine. But we all have bad days, so you should develop the ability to list them out for when you're feeling stuck. Okay, now there's all the factor pairs for 24. Now the trick here is finding the factor pair that matches the middle term. We've done this before, but now it's not just the constant term, it's that product, the thing we got by multiplying the numbers, going after 11x. Now this next bit is going to be the super strange part. I'm going to rewrite the expression, so 2x squared plus, and then now it's 3x and 8x plus 12. Now you might wonder, whoa, but the 3x and the 8x, that was the 11x split into two pieces using that factor pair. This is what we call splitting the middle term. Now when you do that, you set up now 4 pieces, and we're going to grab them in groups. The first pair has an x in common, so we're looking for common factors in the first 2 terms, x, leaving us with 2x plus 3. And in the second 2 terms, there's a common 4. That leaves us also with 2x plus 3. And now you might notice that they both have 2x plus 3 as factors, which is true. Boom, chicka boom. So that's one of the factors for the end. And then the other factor is kind of like all the leftover stuff put together, the x and the 4, the things that were factored out. There's our answer right there. 2x plus 3 times x plus 4. Now let's look at the next one. Now in this case, there's a common factor of -2 we can use to factor out at the beginning. This is really helpful because it makes all the other numbers smaller. That's going to really save you a lot of aggravation, a lot of frustration moving forward. You factor out the -2, brings down the numbers, so that now when you multiply the leading coefficient by the constant, it's 3 times -4, which is -12. -12 is not a fun number to work with for factor pairs, but it's better than what it would have been, which is what, -48 at the top there? That's a disaster. So, factor pairs, boom, chicka boom, chicka boom, chicka boom, boom, boom. This is, your normal -12. We're looking for the pair that adds up to 4, because that's the middle term. So -2 and 6. So we're going to rewrite it. 3x squared minus 2x plus 6x minus 4. Now we've split the middle term. Oh, that -2 is fun from the beginning. Okay. Took that 4x and split it into -2x plus 6x. Now looking at the pairs, the first pair has an x in common. By the way, the first pair will always have an x in there. The second pair does not have an x, but there's a 2 in common in both of those terms, leaving us with 3x minus 2. Again, those factors in parentheses match, and I got to tell you, if you've done your job right, they will always match. So 3x minus 2 is one factor. X plus 2, the stuff left over, is the other factor. And there we have it. Oh, wait, but wait, if you look back at the very beginning, there was that negative 2 we factored out. So let's go ahead and put that in. And that's our actual answer. Boom. Factor out common factor first, then engage in this fun, new, incredibly complicated process. All right, let's look at the next ones. Now here, you'll see there's a 2 in common. So you always want to look for that common factor. And I got to tell you, here that's super helpful because the numbers are smaller, and in fact, there isn't a number in front of the x squared anymore. It's just x squared. So you can do old school factoring. Just grab 6. Look for its its factor pairs. And there you go. You want the one that adds to 5. Boom, x plus 2 and x plus 3. With that 2 common factor from before. Now this example that we just did technically isn't from today's topic, it's from the prior topic, so you'll actually see notes about this on the last set of notes. I included it here to show that common factoring business at the beginning can just really make everything easier, even when you're not expecting it. Now here's this last one, I think. It's negative 4x squared plus 9. You want to factor out a common factor. You might originally think, but there's nothing there to factor out. And I'm here to tell you, if it begins with negative, at least factor out a negative 1. That turns the signs around, which makes it much easier to work with. Here I rewrote it as 0x minus 9. And then we'll go ahead and multiply the 4 and the negative 9. This is this new business. That's negative 36. It's got factor pairs. And there's kind of a lot of factor pairs in negative 36. You got 1 and negative 36, negative 1 and 36, 2 and negative 18, negative 2 and 18. We're talking about 3 and negative 12, negative 3 and 12. We're talking about 4 and negative 9, folks. And then negative 4 and 9. And I kid you not, we still have 6 and negative 6. That's a lot of numbers. As a reminder, once you get the hang of this, you are not required to write out all the factor pairs. I am listing them now just to help you continue to visualize what your possibilities are. And here the winner is 6 and negative 6 because it adds to 0. All right. This might look a little strange, but we're going to split up that 0x into 6x and negative 6x. It's taking nothing and making 2 somethings out of it. First pair, there's a 2 and an x common to them. Remember, in the first pair, there's always an x. Sometimes there's a number you can pull out or divide along with the x. The second pair, there's a negative 3. Remember, in the second pair, there's never an x, but there's a number that you can pull out. Hey, look, those 2x plus 3's match. That's one of the factors. 2x minus 3, the stuff left over, is the other factor. Oh, and don't forget the negative 1. But again, if you're worried about looks, you might want to look fly like me. So instead of writing negative 1, you just write the negative sign. Either one of those answers is just fine. So you got the negative 1 in front or just the negative sign in front. They're both correct. The one on the bottom is slightly more beautiful, but sometimes that's not the highest importance. Okay. Here we got some for you to try. As always, I ask you to try them first before you look at the answers. So I'll wait a few seconds so you can pause the video. Try number 1. When you're done, come back and check. I promise you, I will still be here. Hey, welcome back. So if you did number 1, you begin by noticing that you're after negative 24. And negative 24 has that list of factor pairs. That splits the middle term into 3x and negative 8x. When you do the pairing of factoring, you end up with 2x plus 3 and x minus 4. If that wasn't successful yet, please don't be discouraged. We've got some more to try. If you look at number 2, I want to highlight, it starts a little spunky style because they all have x's, and you can divide them all by 2. So you can factor out a 2x at the very beginning. Again, remember, you always want to pull out those common factors. Now that that's been done, try to proceed with the rest. That means the stuff in parentheses. as always, I promise I will still be here. So go ahead, pause the video, try number 2. I'll still be here when you get back. Hey, welcome back. So we got the 3 and the 10. That makes 30. Factor pairs are there. That splits up the 17 with a 2 and a 15. Factor out common factor pairs. Boom. 3x plus 2, x plus 5. Oh, and our friend 2x from the beginning. Boom, boom, bam. We're done with number 2. We're feeling it. Now, look at number 3. See what you can do here. So I'll pause a few seconds. You can get started, see how well you can do it. I promise I'll still be here when you get back. Hey, welcome back. So there's a 3 that factors out at the beginning. That makes x squared minus 16. Now, in this case, I didn't show all the work because this is an example of difference of squares. A lot of you recognize that already, which is great. If you don't yet, you certainly can do all the work. You can do the 0x, negative 16, factor pairs, the whole kit and caboodle. You can definitely do that. You might also just say, oh yeah, look, plus 4 minus 4 done. That would work too. All right, look at number 4. Please try it. I'll wait a few seconds so you can pause the video. I promise to still be here when you get back. Hey, welcome back. So on number 4, going to go ahead and factor out a negative 2 at the beginning. That common factoring at the beginning is something that a lot of people lose sight of. You want to try to fight to remember that. Then, boom, 3 and negative 8, make negative 24. There's all the factor pairs. There's the middle term split into negative 4x plus 6x. And at the end, boom, negative 2. Boom, 3x minus 4, bam, x plus 2. Factoring done. Now, a couple more to try. So, if you would please... Oh, I totally lied. Sorry. There are not a couple more to try. Here it is. We're done. Thanks for watching. Please let me know if you have any questions.